Hey guys, welcome back to Michelle's STEM Journey. I'm Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2018, 10B, Problem 17, and it deals with geometry. I hope you guys enjoyed this video and let's get started. The problem states, in rectangle PQRS, PQ equals 8 and QR equals 6. Points A and B lie on line PQ, points C and D lie on line QR, points E and F lie on line RS, and points G and H lie on line SP, so that AP equals BQ, which is less than 4, and the convex octagon ABCDEFG is equilateral. The length of a side of this octagon can be expressed in the form k plus m times the square root of n, where k, m, and n are integers, and n is not divisible by the square root of any prime. What is k plus m plus n? So the problem is just asking us to find out the length of a side of the octagon. And so we can just draw out what we are given. So we know that we have a rectangle PQRS. PQ equals 8, QR equals 6. A and B lie on PQ. C and D Okay, so these are all the points that were given, and it tells us that the convex octagon ABCDFG is equilateral. So this is not drawn on a scale, but if we connect all of these lines, or all of these points, we would get an octagon, which, again, this is not drawn on scale, but just imagine that all of these lines are supposed to be equal to each other. So I'm going to set the length of the equilateral octagon to be x. So for example, AB would be x. And the line BQ can be expressed as 8 minus x divided by 2. Because the whole length PQ is 8, and then x is the center part, which is AB. And we know that AP equals BQ. So we can just divide 8 minus x by 2. So essentially what I want to do is I want to figure out what BQ would be, or can be expressed as in terms of x, and then we can multiply BQ by 2 and then add x to that to get 8. So that's an equation, and then we can just solve for x, which would be the length of the octagon. Well, like I said, we know that BQ right now can be expressed as 8 minus x divided by 2. And then we have a Pythagorean theorem right here with the triangle BQC. So this triangle, we know that would be BQ squared, which is 8 minus x over 2 squared. BQ squared plus QC squared equals BC squared. And BC is just x, because remember, all of these are the sides of the octagon. So that's just x. Well, from this we can get QC squared is equal to x squared minus 8 minus x over 2 squared, and then take the square root to get the square root of x squared minus 8 minus x over 2 squared. So that is QC. Well, since QC equals dr, these two are the same, we can say that x plus 2 times the square root of x squared minus 8 minus x over 2 squared, this equals 6. So essentially what I did right there is the same thing as BQ times 2 plus x equals 8. So they're all the same concept, but the reason why I didn't use the original one involving BQ is because if you multiply BQ times 2 and they add x to it and you set that equal to 8, it's just all going to cancel out. Like this, and you multiply by 2, it's going to cancel out, and then this equals 8. You move 8 over, and so x is just going to equal 0. So that's why I chose it to represent this side. So we can not only solve for x, but we can actually get an actual real answer, because we're setting that equal to 6, and we actually have a complex equation here. So now the next step is to just simply solve for x. what we can do is I'm going to subtract x over to get this equation right here, and then we can divide by 2. And then we can square both sides. And now to get rid of the denominator, I'm going to multiply everything by 4. Now I'm going to FOIL out everything and then simplify the left side and the right side. Now I'm going to move everything to the one side. Okay, so this is what we're left with, and we can't solve this by factoring, so I'm going to have to use the quadratic formula. Okay, so this is what we got. X equals -7 plus or minus 3 times the square root of 11. Now we can discard the negative solution because the side can't be a negative number. So what we would actually get is -7 plus 3 times the square root of 11. And what we know is that it's in this form, k plus n times the square root of n. So in our case, it would be -7, 3, and 11. And we should have to add this up to get 7.